Next, general chemical properties. General chemical properties. General chemical properties. In general chemical properties of 15th group elements, first one, oxidation states. Oxidation states of 15th group elements: nitrogen, phosphorus, arsenic, antimony, bismuth. Here, nitrogen exhibit all these oxidation states. Even in this reaction, nitrous acid undergoes disproportion reaction. It is the disproportion reaction. In disproportion reaction, nitrogen undergoes different oxidation states. From here to here and from here to here, nitrogen shows different oxidation states. From reactants to products, nitrogen exhibits two different oxidation states in product side. It is a disproportion reaction. Phosphorus exhibits different oxidation states. In that, phosphorus exhibit -3, +3, and it is exhibit, rarely exhibit -3, it is exhibit +3, +5 oxidation states. These elements are also arsenic, antimony also exhibit +3, +5 oxidation states. Down the group, +5 oxidation stability decreases. Bismuth exhibit inert pair effect. Due to inert pair effect, bismuth is stable in +3 oxidation state. It never exhibits +5 oxidation state, rarely. Only bismuth in pentafluoride form, it is exhibit +5 oxidation state. Bismuth in +3 oxidation state only stable, due to it is rarely exhibit or never exhibit +5 oxidation state, due to bismuth is affected by inert pair effect. Inert pair effect. Inert pair effect is nothing but the reluctance of ns orbital containing electrons participating bonding is called as inert pair effect. Due to inert pair effect, bismuth shows only +3 oxidation state. Inert pair effect is generally we are observed in thallium, lead and bismuth elements. It is due to inert pair effect, thallium is stable in +1 oxidation state, lead is stable in +2 oxidation state, bismuth is +3 oxidation state is stable in their respective groups. Like thallium is the third A group elements, except thallium remaining elements are shows +3 oxidation states are stable. But for thallium, most stable oxidation state is +1 due to inert pair effect. Similarly, lead is generally it is belongs to fourth group. In fourth group elements, most stable oxidation state is +4. But for lead, it is stable in +2 oxidation state due to its inert pair effect. Bismuth is also due to inert pair effect, it is stable in +3 oxidation state. Like phosphorus, stable in +5 oxidation state, down the group +5 oxidation stability decreases. It is about oxidation states. Next, in general chemical properties. Next one is reaction with hydrogen. Reaction with hydrogen. 15th group elements, reaction with hydrogen to form EH3 type of hydrides. 15th group elements, reaction with hydrogen. It forms EH3 type of hydrides. In these hydrides, E is equal to any 50A group element. Nitrogen, phosphorus, arsenic, antimony, bismuth. Here, if it is these hydrides acts as a reducing agents, the reducing nature from nitrogen to bismuth increases. Reducing property from nitrogen to bismuth increases. Next, melting points and boiling points. The melting and boiling points of these hydrides is, it is the order. First, boiling points order. Ammonia shows more boiling point than bismuth hydride, than arsenic hydride, than antimony, than phosphine. Phosphine is shows low melting and boiling point due to phosphine is a gas. Phosphine is a gas. Here ammonia is a easily liquefied gas. Ammonia is easily liquefied gas. Ammonia is easily liquefied gas due to it shows hydrogen bonding. Ammonia shows hydrogen bonding. Due to ammonia shows hydrogen bonding. Due to intermolecular hydrogen bonding present in ammonia, it shows more boiling point than corresponding hydrates of 15th group elements. These hydrates melting points order is, it is the boiling points order. Next melting points order is, the melting points order is ammonia is greater than antimony is greater than arsenic hydride is greater than phosphine. Boiling point order is, antimony hydride is greater than, ammonia is greater than, arsenic hydride is greater than phosphine. These are boiling points and melting points order. And these hydrides are shows pyramidal structure with sp3 hybridization. One lone pair is present and these are shows pyramidal structure. These hydrides of 15th group element. Hydrates of 15th group elements are pyramidal structure with sp3 hybridization. It is the reaction with hydrogen and reducing nature. Reducing property is ammonia is from ammonia. Reducing property ammonia is greater than phosphine. Phosphine is greater than arsenic. It is greater than antimony. Antimony is greater than bismuth. Down the group, reducing property of these hydrides is decreases. Ammonia is strong reducing agent than bismuth hydride. Next to thermal stability. Thermal stability order is down the group decreases. Ammonia is more thermally more stable than phosphine, than arsenic, than antimony, than bismuth. Thermal stability down the group decreases. Next, bond distance between central 15th group element and hydrogen is bond distance or bond length. Bond length down the group increases. From ammonia to bismuth hydride increases. As a bond length or distance between central atom and hydrogen increases, its dissociation energy decreases. Dissociation energy from ammonia to nitrogen hydrogen bond to bismuth hydrogen bond decreases. It is the reaction with hydrogen. Next, reaction with oxygen. 15th group elements reaction with oxygen to form their oxides. These are forms except nitrogen. Remaining are forms common hydrides are E2O3 type of oxides and E2O5 type of oxides. Nitrogen forms different types of oxides for nitrogen oxides. And nitrogen forms nitrous oxide, nitrogen monoxide, nitrogen dioxide, nitrogen trioxide, nitrogen tetroxide. Even nitrogen is also forms into pentoxide. In these two oxides are neutral oxides. NO2 is a nitrogen dioxide and N2O4 both are it is an acidic, it is an acidic oxide. N2O3 and N2O4 are, these are acidic and basic, acidic and basic. N2O5 is only acidic, strong acidic. Most acidic oxide in nitrogen oxides are N2O5 is strongly acidic. The number of oxygens increases for a given element, its acidic nature increases. And here, except nitrogen, remaining elements like phosphorus forms P2O3 type of oxide is exist in dimer form. The dimer form of phosphorus trioxide is P4O6 and the dimer form of phosphorus pentoxide is P4O10. Both are acidic, phosphorus oxides are acidic. And in this P4O6 and P4O10, like it is the P4O6 structure, it is the P4O6 structure. In P4O6 structure, phosphorus oxygen phosphorus bonds is equal to phosphorus oxygen bond, POP bonds 1, 2, 3, 4, 5, 6. POP bonds are 6. Only phosphorus oxygen bonds are, phosphorus and oxygen bonds are around this phosphorus 1, 2, 3. For every phosphorus same 3 oxygens around the phosphorus. So 4 3s are 12. It is P4O6. In case of P4O10, phosphorus, oxygen, phosphorus, oxygen, phosphorus, oxygen, phosphorus, oxygen, phosphorus. And in P4O10, every phosphorus connected with the another oxygen, one more oxygen in the form of coordinate covalent bond form. So here POP bonds in P4O10, it is P4O6. In P4O10, POP bonds is equal to 6. Okay, 1, 2, 3, 4, 5, 6. Now POP bonds. POP bonds are 6. Phosphorus oxygen bonds are, one more 4 is increases, that is 16. And it is P4O6 and P4O10 structures. Next to arsenic and antimony. Arsenic and antimony forms its trioxides and pentoxides. Trioxides and pentoxides. Both arsenic and antimony, they forms its trioxides and pentoxides. As compared to pentoxides, these are stable. Trioxides are stable as compared to pentoxides. And in trioxides, the trioxides as compared to pentoxides, these are basic, these are acidic. Now these are acidic oxides. These are stable and these are basic. Next, reaction with halogens. Reaction with halogens. Here 15th group elements reaction with halogens to form EX3 type of halides and EX5 type of halides. EX3 and EX5 type of halides. In oxides, bismuth forms only trioxide only. It is never forms pentoxide, and the trioxide form of bismuth is basic. Here, except bismuth, remaining elements are forms. Bismuth forms only bismuth trihalides, and bismuth only exists in pentafluoride form, but remaining any compound not exist in pentafluoride form. Like phosphorus Phosphorus exists in PCl5 and PCl3 form, but phosphorus never exists in PF5 form. It is unstable. Phosphorus is stable with chlorine, PCl5, PCl3 form, as well as PBr3 and PBr5, but most stable in this. Here E is equal to any 15th group element. Exception one is bismuth. Bismuth forms only trihalides. Bismuth form pentahalide with fluorine only. Next, nitrogen. Nitrogen forms only trihalides. Nitrogen never forms pentahalides. Nitrogen is also forms only trihalides. Nitrogen never forms pentahalides. And nitrogen halides are also least stable. They easily decompose. And these are halides. In these halides, trihalides are EX3 type of halides. In EX3 type of halides, central atom shows one lone pair of electrons, and these are shows like this structure with sp3 hybridization. sp3 hybridization with pyramidal structure. In EX5 type of halides, EX5 type of halides, best example is phosphorus. Phosphorus in PCl5 form, phosphorus is a central atom. 2 chlorines are exist in axial, 3 chlorines are present in equatorial positions, and it shows trigonal bipyramidal structure. And in trigonal bipyramidal structure with bond angles, it shows PCl5 shows different bond angles, and phosphorus atom shows sp3d hybridization, no lone pairs. Bond angles are 90 degrees, 120 degrees and 180 degrees bond angles. 3 different bond angles are possible only in PCl5 molecule with sp3d hybridization. It is the reaction with halogens. In this reaction with halogens, pentahalides are more covalent than trihalides, and pentahalides more covalent than trihalides. Like in PCl3 and PCl5, which is more covalent means PCl5 is more covalent than PCl3. And like in case of nitrogen also, in nitrogen halides, nitrogen fluoride is least covalent. Covalent nature is fluorides are less covalent than chlorides. Chlorides are less covalent than bromides. Bromides are less covalent than iodides. Next, last one is reaction with metals. Reaction with metals. In 15th group, nitrogen and phosphorus reaction with metals to form its compounds. Like nitrogen reaction with metal, it is forms calcium nitride. Phosphorus is also reaction with calcium, it is forms calcium phosphide. So in 15th group elements, nitrogen and phosphorus reaction with metals, they forms its nitrogen forms its nitride, phosphorus forms its phosphides. But remaining elements are no reaction with metals, especially nitrogen, phosphorus only reaction with metals. And in 15th group elements, allotropes, except to nitrogen, remaining elements are shows allotropic forms. Allotrope means the element which exists in 2 or more than 2 different physical states, that is called allotrope. Okay, now allotrope is nothing but the element which is existing 2 or more than 2 different physical states. Here, except nitrogen, remaining rest of the remaining elements of 15th group all are shows allotropes, allotropic forms. And catenation property. Catenation property. The catenation property in case of single bond, in a phosphorus single bond is more strong than nitrogen and nitrogen. then arsenic and arsenic is greater than antimony and antimony. It is the catenation property of 15th group elements. Phosphorus single bond is more stable than nitrogen and nitrogen. In single bond form. In triple bond form, nitrogen triple bond is more strong than phosphorus and phosphorus bond. These are the general chemical properties of 15th group elements. Now in 15th group elements, nitrogen, important compounds of nitrogen is nitrogen, dinitrogen. Its preparation. Now dinitrogen preparation. Dinitrogen is prepared from the pure form of, very pure form of dinitrogen is prepared from barium azide. Like barium azide on thermal decomposition, it is gives barium element plus 3 moles of nitrogen gas. It is a very pure form of dinitrogen preparation. Barium azide, by thermal decomposition, it gives barium plus 3 moles of nitrogen gas. It is the very pure form of nitrogen preparation. Even sodium azide, 2 moles of sodium azide, by thermal decomposition, it is also gives purest form of nitrogen. The very pure form of nitrogen is prepared from barium azide. Even it is also prepared from ammonium dichromate by thermal decomposition. It is by thermal decomposition releases nitrogen gas. Nitrogen gas plus it is loss of 4 moles of H2O plus Cr2O3. And even ammonium chloride reaction with sodium nitrate. Sodium nitrate. It is forms releases nitrogen gas plus loss of 2H2O plus sodium nitrate. Nitrogen gas plus 2H2O plus sodium chloride. These are the preparation methods for even ammonia reaction with cuprous oxide. Ammonia reaction with cuprous oxide releases nitrogen gas, plus 3 moles of copper or copper plus 3 moles of H2O. These are the preparation methods for dinitrogen. It gives 100% pure form of nitrogen gas. So based on this, question is given like, in which of the following reaction, they give 4 reactions in exam, which of the following is not releases nitrogen gas? So we observed here, from these reactions only dinitrogen is releases, in remaining other reactions dinitrogen is not a product. These are the preparation methods for only nitrogen gas. Next, dinitrogen is a colorless gas and non-toxic. Colorless, odorless, non-toxic gas. Okay, and in between nitrogen, it is a diatomic molecule. Between nitrogen and nitrogen, there is a triple bond is present. Triple bond, 1 sigma and 2 pi bonds are present in dinitrogen. It is liquid nitrogen. Liquid nitrogen shows boiling point is 77.2 kelvins. Liquid nitrogen boiling point is 77.2 kelvins. And nitrogen is existing 2 isotopic forms. Nitrogen exists in 7 with 14 atomic mass. At the same time, nitrogen with atomic number 7 with 15. It is exist in 2 different isotopic forms. Atomic number same, different mass numbers. Nitrogen exists in two isotopic forms. In chemical properties, nitrogen gas is less reactive due to its stable triple bond between nitrogen and nitrogen. Chemical properties of nitrogen. In chemical properties of nitrogen, between nitrogen and nitrogen is triple bond is present. To break the nitrogen triple bond required more amount of energy, so these are chemically less reactive. Dinitrogen is less reactive. In the chemical properties, first reaction with dinitrogen, reaction with metals, non-metals. Mostly it is reaction with metals as well as with non-metals. Like reaction with metals, it is forms metal nitrides. Like nitrogen, reaction with any first A group element like sodium, first A group element, reaction with nitrogen, it is forms sodium azide. It is forms sodium azide. Like it is forms like this type of Na3 N type of azide. So 6 moles of sodium reaction with 3 moles of nitrogen, it is forms 2 moles of sodium azide. If magnesium, second group elements, reaction with nitrogen, these are forms magnesium nitride form. If it is reaction with non-metals, reaction with non-metals, like it is reaction with non-metals, 3 moles of hydrogen gas reaction with 1 mole of nitrogen gas. In the presence of iron is used as a catalyst. It is forms 2 moles of ammonia gas. It is the Haber's process. In Haber's process, ammonia, it is forms, it is delta H is equal to minus 92 kilojoules amount of energy releases. It is an exothermic process. Nitrogen reaction with hydrogen to form ammonia. Next to nitrogen reaction with oxygen. It is forms different types of oxides. It is forms 2 moles of 1 mole of nitrogen reaction with 1 mole of oxygen to form 2 moles of nitrogen monoxide gas. It is a colorless gas and neutral. It is delta H is equal to plus 180 kilojoules amount of energy absorbs. It is an endothermic reaction. These are the general chemical properties of nitrogen. Dinitrogen gas majorly used in preparation of storage of food materials. Like chips packets contains nitrogen gas.